Let us discuss normalization, a topic in database management system. It is the process of analyzing a relation schema It is the process of analyzing a relation schema R in terms of functional dependency, and in terms of functional dependencies and primary key. Primary key in order to achieve the following, in order to achieve the number one, minimization of redundancy, minimization of redundancies and minimization of redundancies and insertion, deletion and updation anomalies. Then we'll see what is normal form. See what is the normal form. A relation refers to highest normal form. A relation refers to highest normal form, that is also termed as degrees normalization. After another, some fundamental concept of that, what is we have to know what is functional dependency. So what is that FD? So to explain the functional dependency FD, let us take a relational schema, a relation state R with three attributes. And with possible functional dependencies. So what I have to write here? A, B, C. Let this is A1, okay, and A2, A3. Similarly, let's take this is B1, B2, B3, B1. And let's take C1, C2, C3, C4. What are the FDs are there here? Functional dependency. We will find here A and B both combinedly form a functional dependency. C provide a functional dependency to B, whereas A tends to C does not hold good, and B tends to C does not hold good. So what is that functional dependency? The definition of the function. So history. The normalization process was first proposed by Cord in 1972. The process of decomposing a relational schema into smaller set of relation schema, right? In relational database design, Cord first propose three normal forms. One NF, first normal form, 2 NF, second normal form, and 3 NF. And latter stays both Boise and Cord propose a stronger form of 3NF normal form called Boise chord normal form. B, C, and F. All these normal forms are based upon the functional dependencies and primary key. First is two more normal forms was invented called fourth normal form based upon multi-value dependency and fifth normal form based upon joint dependency. Respectively. Now we will go one after another that what these normal forms are there. The very first one is called first normal form. One and F. A relation is in 1 and F if each attribute in the relation are atomic values. Now we'll see best example here. One of the best example. Suppose we have to take a relation here A, B. Here it is written A1 and here it is written B1, B2. Here it is written here A2, here it is written here B1. Something like that. So, if you look at this attribute B, in this first cell value, it is not atomic. We can decompose this relation into atomic here. We convert like that A1, B1, A1, B2, A2, B1. So a relation is in first normal form if each attributes in relation are atomic values. are having atomic value. Second normal form, it is also called 2NF. A relation schema when I am telling that a relation schema, it only talk about the structure, right? A relation schema is in 2NF, is in 1NF, and every non-prime attribute are fully functional dependence, fully functional dependence. Take an example here. Suppose we have a relation R having three relation schema, and let me say that even if this is also whole good. So what is saying that A, B both tends to C, B tends to C. Here B tends to C is a partial FD. So what is that idea? Here AB, you should give an underline here. Here it combinedly form a primary key. And A and B are prime attributes. This is the second attribute. So this example BC, as this is whole good, it does not satisfy the second normal form. This relation schema does not satisfy to NF. Does not satisfy to NF. On primary key of relation R. On primary key of R. Every non-prime attribute are fully functional dependent on primary key of R. That is, Here C is a non-prime attribute. Here C and C is a non-prime attribute. Now, what is called third normal form? A relation schema is in third normal form if it hold 2NF and no non-prime attributes are transitively depend upon the primary key. If it hold good second normal form and no non-prime attribute are transitively depend upon the primary key. Let us take one of the example here. Employee number determine employee name, birth date, address and department number. Department name, manager number. So here transitive dependency exists. So transitively depend upon the primary key. Here SSN is the primary key. Only one primary key there. Now department number is a non-prime attribute. Non-prime attribute. Department, now if you see that there is a relation introduced here, SSN tends to manager number. So a relation schema is 3NF if it is hold second normal form and no non-prime attributes are transitively depend upon the primary key. So this is not in 3NF. Now we are discussing on third normal form, right? So what is that third normal form? Look at that here. A relation schema is in 3NF if it holds 2NF and no non-prime attributes are transitively depends upon the primary key. This is and let me take one example here. SSN is employee number, functionally determine employee name, birth date of the employee, address, department number. Let me explain you that this employee name, birth date, address, department number all are non-prime attributes. So we have another functional dependency, department number, determine department name and manager number. So here there exists a transition dependency. If you see here the transitive dependency, so I can write like this, SSN, okay, and I can write here employee name, I can write here birth date, I can write here address, and I can write the department number. Make a relational schema. Now these hold good the relation 1, 2 and 3 and 4. Secondly, what happened that we have one more dependency relation. I can write here, we can continue with this one. This is department number, department name and manager number. So because this is a relational schema, this is the relational schema. How many attributes of the relational schema? 1, 2, 3, 4, 5, 6, 7. So one of the functional dependency hold good. SSN determine employee name, birth date, address and department number. And another functional dependency that determine manager number and department number. So here there exists a transitive dependency upon the primary key, SSN number. SSN determine MGR number. So it is not in 3NF. Now let's go to the strongest form of normal form based upon the functional dependency. We call Boyce-Codd normal form. If you see the definition of the Boyce-Codd normal form, it is the stronger form of 3NF, means it is in 3NF, and if whenever a non-trivial functional dependency X determine A exists, what I said that there exists a non-trivial functional dependency X tend to X determine A, then X is a super key, is a special case. But here if you see that other definition of the 3NF, we can also write a relation. Second definition also you can write a relation in 2NF, and there exists a functional, non-trivial functional dependency where X is a primary key or Y is a prime attribute. Try to understand. Is a prime attribute. I repeat again, a relation in 2NF and there exists a trivial, non-trivial functional dependency FD X tends to or X determine Y, where X is a primary key or Y is a prime attribute or is a prime attribute. Either this way you can write the definition or you can write this way the definition. Next is that we are discussing on Boyce or normal form. It is the stronger form of 3NF. Means if you see that the form of that BCNF is in 3NF. This is, and similarly we can write here, what you can write here, 2NF, and we can write here 1NF. So these, okay, the concept introduced of the normal form. Now, what is Boyce-Codd normal form? It is the stronger form of 3NF, means it is in 3NF, and whenever a non-trivial functional dependency X determine A exists, then X is a super key of R. We call it super key or we call it a primary key. So now let us take one of the examples to understand all the normal form that depend upon the FD. So what are the normal forms that depend upon the FD? So these are 1NF, 2NF, 3NF, BCNF. So right now let us take one example. Consider a relation with attribute. Let there are 10 attributes A, B, C, D, E, F, G, H, I, J with the following functional dependencies. What are the functional dependencies given here? If you see here, AB determines C, F determines GH, A determines DE, D determines IJ, and B determines F.
सुदर्शन साहू के
Okay, we are discussing on repeatedly. Let me first go into that. What I am trying to explain, that Boyce-Codd normal form, which is a stronger form, that is in 3NF, 3NF in 2NF, 2NF in 1NF. First normalization form. So that also I discussed here. So let have a quick a review of all the types of the normal form. First normal form, second normal form, third normal form, BCNF. All these are depend on the FD, functional dependency. So consider a relation R with 10 attributes A, B, C, D, E, F, G, H, I, J. Having FD, let me having the FD here, and AB determines C, F determines GH, A determines DE, D determines IJ, and B determines F. B determines F. So here we will see that the given relation R in which highest normal form. The degree of the normalization we will see here. The degree of the normalization see here. Here then if you see the degree of the relationship, in which highest degree, in which highest normal form this belongs. So first of all, we have here explained that step 1, if dependency given, then relation by default is in 1NF. We don't have to go for check the relation state. No need to check the relation state. Step number 2. So now we will test for the second normal form. The second normal form says that the relation second normal form, it is in NF, 1NF, and every non-prime attributes are fully functional dependent on primary key of R. So what is that idea here? Here if you look at this one picture, AB is the primary key. AB closure we find out here, it covers all the attributes, all the 10 attributes here, and AB is the primary key. That is the first things that we have to do. Second, that we will check here AB determines C, it is hold good, no problem in that. Now look at that one more, A determine DE, question into that. F determine GS, there is no such problem in this, no such problem in that. And A determine DE, AB determine C. A is a prime attribute of key A, B. So this is a partial dependency. Similarly, B determine F. In you look at that, B is a prime attribute, part of the key, and it is a partial dependent. So A determine D and B determine F have the partial dependency to primary key. Hence it is not in 2NF. We discuss. Now what we have to do? Step number 3. Now we have to decompose the given relation R into smaller ones that hold or cover full functional dependencies. Full means that all dependency it must hold. Because by trivially or by default, AB determines C is there already. We can make a relation AB determines C. We can make, if we find this is a partial dependence, there is some clue here. First we have to find the A closure here. So we will find the A closure, it cover A, D, E, I, J. With if FD, A determine D and D determine IJ. It cover, what it cover here? A, D, E, I, J. Second we will see that B plus, what is covering here? B, F, G, H. This is also hold good. Now we decompose the given relation R to 3 relation R1, R2 and R3, which hold all the FDs into that. So now very next, Now we have to check the 3NF in R1, R2 and R3. If you will see, if no non-attribute are transitively dependent upon the primary key, we call the relation is in 3NF. No non-prime attributes are transitively dependent upon the key, upon the primary key, we call the relation is 3NF. But look at the 3NF, R1 with 3 attribute is in 3NF because it is a full functional dependency. But coming to the relation, but the existence of transitive dependency determine Ij. This is called transitive dependency because A, what is the idea here? Why it is a transitive dependency? Because A determine, what is that here? A determine D, E and D determine Ij. A determine D and D determine Ij. Here there is a transitive dependency exists. So it is not in 3NF. Now coming to that BFGH with having relation, having attribute in relation R3. Here B determine F and F determine GH. So there is a transitive whole good and it is not in 3NF. Now what I have to do in that case? Decompose further into to retain into 3NF. So what I have to do that? We have to eliminate transitive dependency, and as per our definition, every non-trivial FD, X is a primary key or Y is a prime attribute. What we did here, we find every such FDs and we make a table or relation ताकि we should not have any transitive dependency. So we convert this, R1 is already there, no need to, there is no transitive dependency exists here. Now R21, we decompose R2 into two relation, R21 and R22, and look at that, here A is the key here, no problem. Look at here R22, T is key here, no problem in that. R31, B is key here, no problem here. And R32, FGH and F is the key here. So this is also hold good. Now coming to the step number 6, that now can you further decompose into BCNF? But BCNF, there is a very special case of 3NF. It is a stronger form of the 3NF. What it speak about that? You choose for any relation. We have such 4 relation that the FD for the relation, any FD, let FD for the relation R1 in the form X tends to Y. X must be a primary key. Yes. Now you can see that there exists a FD, AB is the primary key. Similarly R21, there exists FD, one FD and A is the primary key. Similarly R22, there exists one FD and D is primary key. In R31, there is FD, F determine F and F is the primary key. And in R32, F determine GH and F is the primary key. So henceforth we discussed that the resultant decomposed relational schema, okay, relational schema database having R1, R2, R2, R3, R3, 2 are in BCNF form.